In this video, we will talk about the very basis of organic chemistry. Now, many people take organic chemistry classes and they don't even know what organic chemistry is all about. We will talk about what organic chemistry actually entails, what really goes into organic chemistry. Now, with my own definition of organic chemistry, I'll say organic chemistry is a chemistry of compounds that contains the element carbon. So without carbon, there is no organic chemistry. Now, organic chemistry is a branch of chemistry that encompasses many classical subdisciplines such as inorganic chemistry, physical chemistry, and analytical chemistry. In other words, you find a little bit of organic chemistry in inorganic chemistry. You find a little bit of organic chemistry in physical chemistry, so as in analytical chemistry. And going further, you will find a little bit of organic chemistry in material science, physical biochemistry, and then so on. And now, organic chemistry is all around us, and then how are we going to see the effect of organic chemistry in our lives? We will talk about organic compounds, which has to do mainly with organic chemistry. Now, talking about organic compounds, what is organic compounds in the first place? We have compounds, which actually is the chemical combination of two or more elements in fixed proportions. And we have organic here, which has to do with carbons. So organic compounds will have an element carbon in it. So how do I define organic compounds? Organic compounds are chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, mostly hydrogen, oxygen, nitrogen, and so on. So it can be one or more atoms of carbon. It can be one carbon, two carbons, three carbons, four carbons, and they are covalently linked to atoms of other elements such as hydrogen. So the first carbon can be linked with a hydrogen, maybe the second with an oxygen, the same with a nitrogen, and then so on. And talking of organic compounds, what are some of the organic compounds we will encounter in our daily lives? Some organic compounds we will encounter is the popular methane. Methane is the main component in natural gases. Natural gases is all around us, and the chemical formula for methane is CH4. This is the structural formula with C and a hydrogen which is bonded to it, another hydrogen, another hydrogen, another hydrogen. So C with four hydrogens bonded, and we have to know that carbon actually forms four bonds, of which we are going to talk more about in the video. And now, a second example of organic compounds in our daily lives is what we call ethanol. Ethanol is what we find in alcohols, and the chemical formula is C2H5OH. And this is a structural formula which has two carbons having hydrogens all around it, and the OH, this OH shows that it is an alcohol. And we have to know that carbon actually forms four bonds, and then it can form the four bonds in four single bonds. So one bond can be here, another can be here, another can be here, and then the last one can be here. It can also form two single bonds and one double bonds, making four bonds. It can also form one triple bond and then one single bond, making four bonds. And then it can also form two double bonds. So basically, carbon actually forms four bonds. And with the four bonds, how does carbon actually form four bonds? Now, carbon, it has four valence electrons, and with these four valence electrons, it is looking to covalently bond with four different elements. And then with this, taking methane as an example, we have a hydrogen with a valence electron of 1, another hydrogen with a valence electron of 1, the same hydrogen, and then it brings up its electron to come and covalently link with this particular electron over here, same as this, same as this. So they covalently link. That is how we get a methane. So four hydrogen atoms. The hydrogen has a valence electron of 1. Carbon has valence electrons of 4. Looking for four bonds. Looking for four bonds. That is how carbon actually forms four bonds then. Now we look at some terminologies over here. A stable carbon is known as a tetravalent carbon. A stable carbon is known as a tetravalent carbon. Now, there are other elements apart from carbon and hydrogen that can be bonded, and those elements apart from carbon and hydrogen are known as heteroatoms. Heteroatoms, and examples can be nitrogen, and nitrogen can be bonded with carbon apart from hydrogen. We can get an oxygen, we can get a sulfur, we can get phosphorus, and halogens. And halogens are the element in group 17 on the periodic table, and these are the halogens: fluorine, we have chlorine, we have bromine, we have iodine, we have astatine. So any of these can actually covalently link with carbon in an organic compound. Looking at this, we want to talk very shortly about classification of organic compounds. How will we know this particular organic compounds? We can differentiate organic compounds in different forms, and the first form you talk about is aliphatics. And with the aliphatics, you will have to talk about alkenes, we have to talk about alkenes, and then the alkynes. And we have the alicyclic, which is the second classification, and these are carbon atoms that actually combine to form rings. And when they form the rings, that is how we name them alicyclic organic compounds. And this here is a carbon atom, this is a carbon atom, this is a carbon atom that has actually combined to form the ring. This is also another carbon atom, one over here, making 4 carbon atoms. So they just combine to form that ring, and that is what we term as the alicyclic organic compounds. We have the aromatics, which we talk more about it, benzene. Then we have the heterocyclic. The heterocyclic is the presence of other elements apart from carbons and then hydrogen. So heterocyclics, they are carbon atoms that combines to form rings in the presence of oxygen, sulfur, nitrogen, and probably the halogens. The presence of the heteroatoms, which we have already discussed as oxygen, sulfur, nitrogen, and then the halogens in alicyclic compounds will give you a heterocyclic compound. In the next video, we will talk more about the aliphatic, mainly the alkene. Thank you for watching.